Welcome to your next video, the last section of our geometry chapter, which discusses the Pythagorean theorem and also similar triangles. Now, let's talk about the Pythagorean theorem. I know that for a lot of you, this could be some review. You may have seen this in past courses, but the Pythagorean theorem is working with right triangles. Now, if you remember in our last chapter, we talked about a right triangle. And we said that that is when, remember, you have the 90-degree angle. That would be the right triangle. And when you have a right triangle, we can apply what's called the Pythagorean theorem, which basically you look at two sides. We call that A and B. These are what we call the legs of the triangle. They form the right angle. And then we have the hypotenuse, that is the diagonal that connects the two legs. There is a formula that you can use to find the lengths of the sides, and that's a squared plus b squared equals c squared. Now notice in the notes it says this diagonal always must be the hypotenuse. The legs are what form the right angle. And we can use this in a variety of problems when we have two of the sides, but we might be missing one of the sides. Let's try an example. And of course, I'm going to jump right into a word problem because that's where the struggle usually is. It's not plugging in numbers when we're missing one. It's working with these numbers. The image below shows several city streets in a rectangular grid. The lengths of the individual city blocks are 1/8 of a mile in the east-west direction and 1/16 of a mile in the north-south direction. What does this mean? You look at the diagram here. When you're traveling east and west, right, so to the right, that would be 1/8 of a mile. When you're traveling north, that is 1/16 of a mile. Each of those are blocks. So this would be our north blocks and this would be our east-west blocks. The question that we're being asked then, I'm going to move this down since we've got the numbers in the diagram. How far is the library from the subway along the walking path shown? Here's the library, and that dot up here is the subway. The walking path would be walking along those blocks. So in other words, we go east, north, and so forth. There's a couple of things we need to look at, okay? First, if you follow the walking path, you'll see that it goes now. Think about this. We're doing movements of east and movements of north. That's it. We're following the walking path. That means we're going to be walking some amount of blocks east, right? And some amount of blocks north. All right, well, that's what we need to figure out because that's all we're moving. So how many blocks east are we doing? Well, we have to count. 1, 2, 3, 4, 5, 6. You're doing 6 blocks where you're walking east. How many north? 1, 2, 3, 4, 5. Ooh, be careful. That right there are 3 blocks. So we just did 5, but then we're going to go 6, 7, 8. We're doing 3 blocks north. So that would be 8 blocks total. Okay. Well, we've got how many blocks we're walking, and guess what else we know? We know the distance for each one. The distance of the east-west, if you see right here, is 1/8 of a mile. So that means 6 blocks times 1/8 of a mile, because that's what you're doing for each of those. Plus, we're doing 8 blocks north, and we were told over here that the 8 blocks is 1/16 of a mile. There we go. Well, now we multiply it out. Well, this is going to give me 6/8 plus 8 over 16. Well, let's go ahead and reduce that. If you know 6 and 8, 2 goes into both of those. That would reduce. You're going to divide both of those by 2. That gives me 3/4. So we're just reducing. You don't have to until the end if you don't want to. 8 over 16. Well, 8 goes into both of those. So if I divide both 8 and 16 by 8, we get 1/2. So 3/4 plus 1/2. Now we can change to a common denominator. That would be 4. Remember, you can't just add denominators. 3/4, we don't change that because that was already 4. But the 2, go back to your changing common denominators. That means I have to get to a 4, I have to multiply the 2 by 2, and so the 1 by 2. All right. Well, then that gives me 2/4, which is 5/4. Now think about 5/4. That is 1 1/4, oh, I ran out of room, of a mile. That's the answer to that part. If you were to do the walking path, you would walk 1 1/4 of a mile. Now, what about the second part, B? B says, how far is the library from the subway as the crow flies? That is, along the straight diagonal path. Well, I'm going to go back here. This is your straight, right here. You're looking at this, the straight diagonal path. Well, notice that is a diagonal, and we are talking about right triangles. Notice I can draw a line to here, and then I can go straight up to the subway. Well, that just formed a right angle. And that means I have a length here, we can call that A, and I have a length here that we could call B if we want. And it doesn't matter, you could have called this B and that A. But now I have formed a right triangle. So if I can know the distance of A and then the distance of B, I can use Pythagorean theorem to see how far I would walk along the diagonal. Well, we know how far this is. Actually, we've already figured out, but I'll just show you. We're moving 1, 2, 3, 4, 5, 6 blocks east. And how many blocks north? 1, 2, 3, 4, 5, 6, 7, 8 blocks north. Notice the problem below here. We already found out what that would equate to. We said that if we walked 6 blocks east, that was this part of the equation, then that was 3/4 of a mile. Or let's do decimals this time. So we're going to do it one way with fractions, and now let's do part B with decimals. You just use both, get some practice in. The north walk, what did we say that was? We said that was over here. That was 1/2. Right? Or 0.5. So we have 0.75 and we have 0.5 for the distance. So 1/2 a mile and 3/4 of a mile. Well, that means we're ready. We've got A and B. We're going to go down here and let's plug in using the Pythagorean theorem. So we have we're going to use decimals with this one. So 0.75 squared plus 0.5 squared equals c squared. Now with your calculators, you're just going to square these out. So take 0.75 squared, and we get 0.5625 plus, and then 0.5 squared is 0.25. That equals c squared. Add these two together, right? We need to simplify. 0.8125 equals c squared. Now think about what do we need to do to solve for c? This number is equivalent to c squared. So if we want to find c, then what we're going to have to do is take the square root of 0.8125. That's going to give us the answer for c. Whenever you want to find the answer to a squared, b squared, any of those, you want to take the square root at the end. You can use your calculator and use the square root key, but we're going to round, and it comes to about 0.9 miles. If you take the diagonal, you'll walk just under a mile, but if you were to take the walking path, you would walk about 1.25 miles. All right, let's move on to the next problem. It's mostly word problems today because those are fun. All right, example 2. We want to find the area in acres of the triangle mountain lot shown in the figure. So this is the mountain lot. And if you notice what we're given, we're given the, well, first of all, let me just write down what we need to find. Area. I always like to write things down. Area of a triangle. That would be 1/2 base times height. All right, well, we have the base, but remember we talked about this last week. The diagonal, that is not the base, the height of a triangle. It's always the perpendicular height. That means that this right here is our height. Okay? Well, how can I get that height? I've got the base and I've got the diagonal. All right? Well, remember, we just talked about this. That would be, I'm going to move over here because we'll do the area down there. A squared plus B squared. Remember, you can find any side of a right triangle if you're given 2. Well, I have this one. That's one of the legs. So that would be 250 squared. Plus and B squared. That's our height. That's what we don't have yet. But we know what C is. It says it's 1200. Now, the next step. We need to square these out. 250 squared is 62,500. We don't know B squared. And then if you square 1200, you're going to get 1,440,000. Do you remember what we do when we need to solve for the B squared? We're going to have to bring the 62,500 over. Oops. Well, remember, when you bring, well, look at that. I did not even give you the right number. 62,500. And you know what? I'm just going to erase that. There we go. Remember, when you bring something over to the other side, we got to do the opposite. So now that I'm subtracting, now I'm going to have B squared equals, and now subtract the two numbers, and you should get 1,377,500. That is B squared. So remember, to find B, we're going to take the square root. Well, then that means, and again, let's just round to the nearest whole number for this part. Put in the square root, and we're just going to round. So that's going to be approximately 1,174 feet. All right, that gave us the height. So now over here, we have the height. The height is 1,174. That means we are now ready to find the area. It's 1/2 of the base, so that would be 250, times the height that we just found. If you're using a typical, like a basic scientific calculator, what I would recommend is multiply these two numbers together, then divide that answer by 2, and you'll get the area, which is approximately 146,750 feet squared. But we're not done. Why are we not done? Think about what the question asked. Find the area, right there, in acres. All right, now believe it or not, this is probably in your notes. I think in one of the charts from the measurement and conversion chapter. Yes, you are starting to see previous material coming up. But I'm going to put this down for you. It's in one of your tables that you were given. But 1 acre, now we're going to actually go back and do a review because we're going to be doing some conversions. 1 acre is equal to 43,560 feet squared. Okay, so I'm just going to put that in there because now we have to do a conversion. We've just found the area in feet squared, but now we have to put it in terms of an acre. So then that means we're going to take 146,750 and divide that by how many square feet are in an acre. And let's round to the nearest tenth for this. So when you divide this, that would be around 3.4 acres. And that's your answer. Finally, yes, that was a long one. All right, now let's go down to similar triangles. Similar triangles are basically when you have two triangles, they might be different sizes, but if their corresponding angles are equal, so angle A is equal to the angle A prime that you see here, angle B equals B prime, angle C equals C prime. If they're all equal, then these are considered similar triangles, and that means that the corresponding sides are similar, meaning they have a ratio, they have a relationship, and this is how you could set it up. A to its corresponding side, B to its corresponding side, and so forth. We're going to work with similar triangles with the next two problems, and we can see how we can apply this. So here we have a problem where we want to find the missing sides. We have B and C, but we're missing A. And again, we can't use Pythagorean theorem because this is not a right angle. They would be telling us. And here we're missing the C prime. That's how I use it. All right, well, one side at a time. Use your corresponding sides. The relationship A, okay, corresponds to the A prime. Then that means I'm going to put A over 4, and then equals, and then we have B corresponds to the B prime. Well, we already have those numbers. That would be 9 over 6. Keep the triangles together. We did the large triangle on top, so we'll do the small triangle on the bottom. Same over here, large triangle, small triangle. Don't flip it or you'll get a different answer. Now you cross multiply. So that means 6 times A equals 9 times 4. 6A equals 36. And then 6 times what is 36? 6. Now we're going to go to find the C. Well, the 12 here corresponds to this C. That means I'm going to do 12 over the C prime equals, and we're just going to use the same numbers we used last time. You can do that. And then you cross multiply. So 9 times C prime equals 13 times 6. Okay, well, take 13 times 6 and we get 72. Oops, sorry, that wasn't right. That was 12 times 6. I thought that didn't seem right. And we get 72. And then 9 times what is 72? 9 times 8. So you found the sides that were missing by using ratios or proportions and then cross multiplying. One more. All right, here's an example. Some cities have policies that prevent property owners from constructing new houses or additions that cast shadows on neighboring houses. The intent of these policies is to allow everyone access to the sun for powering solar energy devices. Here would be an example of a policy. On the shortest day of the year, a house cannot cast a noontime shadow that reaches farther than the shadow that would be cast by a 12-foot fence on the property line. Suppose your house is set back 30 feet from the north property line, and that on the shortest day of the year, a 12-foot fence on that property line would cast a noontime shadow 20 feet in length. If you build an addition on your house, how high can the north side of the remodeled house be under this policy? All right, what's happening here is we're looking at the shadows, right? So from the fence to the end of the property is a 20-foot shadow. We cannot go beyond that. From the fence to the house is a 30-foot shadow. So from the house to the property line, that would be a 50-foot shadow. Well, first, let's write down the relationship. Notice that we have similar triangles here. We have this triangle from the fence, and then we have this larger triangle from the house. Hopefully you can follow what I'm doing. That means we have two similar triangles. We have two corresponding sides. We have the house height over the fence height. These are what we're given. That's why we're using it. So you have to look at what am I given. We don't know. Well, I'll get to that in a minute. What's the other relationship? We have the house shadow length. I'll just put shadow because I don't have room. And then the fence shadow length. We are given, well, what we don't have is the height of the house. That's going to be what's going to tell us what's the tallest we can build. Here's all of our numbers. Let's plug it in. House height, that's what we don't know, so we'll just call that H. What is the fence height? That's down here. The fence height right here is 12 feet. Then we have the house shadow. Remember, the house shadow is the long line. Okay, not the house to the fence. It's the house to the length of the property. That's the 50 feet. And then the fence shadow, that's from the fence to the end of the property. So all of these are going to the end of the property. That would be 20 feet. Now we cross multiply. 20 times H equals 50 times 12. Multiply 50 times 12 and you get 600. And then just remember, whenever you're solving at the end and you've got something in front of the variable, that is where we divide. H equals 30. What this means is that the maximum height of the north side of the house after being remodeled can be 30 feet. That is the maximum height they can be. And that, believe it or not, takes us to the end of the entire geometry unit.